In this demonstration, we will explore reduction of oxide by carbon. So now the reducing agent that will be used is carbon. First of all, let's examine the reactivity series of metals, and let's examine where carbon lies within this reactivity series. So these are some metals. Of course, pay attention that carbon is a non-metal and it will be used as a reducing agent. Carbon lies between aluminum and zinc. For a displacement reaction to take place, the more reactive metal will displace the less reactive one. And this means that the metal should be higher in the reactivity series because as we move up, the reactivity increases. So for example, if we compare between iron and aluminum, aluminum is more reactive than iron. So aluminum is able to displace iron. In a similar way, for carbon to be able to reduce an oxide and thus to produce a pure form of the metal must be less reactive than carbon. So it must be below carbon in the reactivity series. For example, zinc, iron, tin, lead, and copper are all metals which can be extracted and reduced by carbon. On the other hand, potassium, for example, which has a much higher reactivity than carbon, cannot be reduced by carbon. So the way that a metal is extracted depends on its place in the reactivity series. So carbon, even though it's a non-metal, it will displace less reactive metals from their oxides. And actually, carbon is used to extract some metals from their ores in industry. We can find many metals such as copper, lead, iron, and zinc, which are combined with oxygen as metal oxides. And because carbon is more reactive than each of these metals, carbon is used to extract the metals from their oxides. How can we do this? The metal oxide will be heated with carbon. Carbon dioxide will be produced and the metal as an element will be produced as well. So carbon will remove oxygen from the metal oxide to form carbon dioxide and the metal will be formed as the element. So the general equation of the reduction of a metal oxide by carbon is metal oxide plus carbon when heated will produce the metal and carbon dioxide CO2. Let's take an example. If we have lead oxide, which is solid, when heated with solid carbon, will produce lead, which is a liquid, and carbon dioxide gas. In this video, lead oxide is heated with carbon. Of course, we can't see carbon dioxide, which is a gas, and this is lead produced. So this animation shows how carbon will displace lead, where lead is a less reactive metal than carbon. So the products will be lead and carbon dioxide. And in this way, the pure metal lead is produced. So this is an example of the reduction of oxide by carbon. So carbon will remove the oxygen and this will produce carbon dioxide and lead.